So, dear audience, I am Dr. Manoj Kumar Gupta, an assistant professor in the Faculty of Engineering and Technology of Swami and Subhash University. So, I am going to teach you the engineering mathematics. In this syllabus of engineering mathematics, I am going to teach you a very important topic. Its name is multiple integrals. You might be aware of the integrations where up to the 12th level, whatever you have studied in the chapter of integration, that comes as the single integration. Okay, the result was called the single integral, but here we are going to learn the multiple integral. Multiple integral means that here we are going to integrate the functions of at least two variables or more than two variables. So, what it means, let us understand. Here in this syllabus, we will discuss two types of multiple integrals. The first one is called the double integral and the second is called the triple integral. So, let us first understand the concept of double integral. So, as you know that here we are going to integrate the function of two variables. Suppose we have a function of two variables x and y, and if we plot the graph on xy axis, it looks like this one. So what we do here, if this area is bounded, like suppose we have to integrate the function f of xy between two limits. Suppose here this one is a and this one is b. Okay. So in a bounded area, we have to integrate the function. So what does the double integral mean? So if we divide the whole region by drawing some steps parallel to x-axis, y-axis, then the whole area is subdivided in small rectangles like this one. Like this. The whole area is divided into small rectangles. If we increase the number of parts, number of divisions of the whole region, each rectangle will be very, very small. It will look like, suppose if the number of parts is n, and if we increase it infinitely, so what will happen? The area of each rectangle will be tending to 0. Very, very small. So what it says, it will look like a point. Okay. So if in each rectangle we find the value of function f of xy and then multiply it by the respective area of the rectangle, it will look like, suppose we have a rectangle which looks like a point and its coordinate becomes x1, y1. So what we will do? We will find the value of function at that point, multiply it by the respective area delta a1. If the whole area is a, then we can assume that the area of each rectangle is very, very small, which is represented by delta a1. Similarly, we can calculate the other products. If we add all these results, all these products, and then take the limiting form, that if we are increasing the number of subdivisions, then the area of each rectangle will tend to 0. So in this limiting form, this result, this summation is called the double integral, which is written as like this. So as you know, the area of the rectangle is, what does the area of rectangle tells us? Suppose its length is x and the breadth is y. So what is the area? X into y. Okay. So if the rectangle is very small, so what we can assume that this length becomes very small like delta x. Similarly, its breadth becomes very small like delta y. Now, what will be the area? It will become delta x into delta y. Very small. So, in the limiting form, since area is very small, it means that x is tending to 0. X is tending to 0 and y is also tending to 0, very small. So this was the concept of double integral. Now we are going to understand the concept of evaluation. How it is going to be evaluated. This is the another form. So here we will discuss the evaluation of double integral in Cartesian form. In the Cartesian form, we have to evaluate the double integral, and how it is done. So it depends upon the situation of the area. Suppose if the region R of area A is bounded by the four straight lines like x equal to A, x equal to B, y equal to C and y equal to D, which is clearly shown in the following figure. So we can see here, if the whole region is bounded by this line, we can see that all the limiting values are constant here. In this situation, that when the region of integration is bounded by four straight lines like x equal to A, x equal to B, y equal to C and y equal to D. Okay, so here it is very obvious that the limits of both the variables x and y are constant. So after drawing on the graph paper, it looks like a rectangle. Okay, so here the limits are constant. In that situation, what we do here, we integrate the function f of xy in any order. See, we have to integrate the function with respect to both the variables like x and y. So we have to choose the order that which variable should be used first for the integration. So here we can choose any order since the limits are constant. So either we can integrate the function with respect to y first and then with respect to x, or with respect to x first or then with respect to y. In both the situations, we have to note that we have to use the partial integration. Remember this is a very important point, that we have to apply the partial integration, that whatever the variable with respect to which we are performing the integration, another variable will be treated as constant. Like when we are integrating the function with respect to y first, then we have to choose x as the constant, and then when we are integrating the function with respect to x, then we have to take y as the constant term. Okay? So this is a very important step which we have to note in our mind, and then we are moving to the next step. Okay? So next step we will discuss another situation. Okay. So what we are going to do here? In this situation, what we will do? In this situation, when the limits of both the variables are not constant, so the question is that which order should be selected for the integration. So here we will integrate the function with respect to that variable first whose limits are in variable form, and then at the end we will integrate the function with respect to that variable whose limits are constant. So here we can easily see that the limits of y are variable. So we will integrate the function f of xy with respect to y first, and since the limits of x are constant, we will choose it in the latter step. So here the whole thing is summarized here like this. So whatever the order we have to choose, we have to make, suppose if we are integrating the function with respect to y first, then we have to make it as an internal integral, and since we are going to integrate the result with respect to x in the latter step, then we will make it as the external integral. So this is the internal and this is the external, innermost, outermost. Okay. So here the inner integral is also written here, that evaluated first, taking x as the constant, because as you know that I have already explained that we are using the partial integration. So whenever we will integrate it with respect to y, we have to choose x as a constant. Now the third situation. The third situation says that here, suppose in this situation the region is bounded in such a way that the values of x are variable and the limits of y are constant, like this. So whenever we can draw it on the figure, okay, and then in this situation what we will do? In this situation we will integrate the function f of x y with respect to x first, because its limits are variable, and then in the second step we will integrate the function with respect to y because its limits are constant. So again the same thing here. So here when while evaluating the internal integral with respect to x, again we have to choose y as a constant, and in the latter step we will integrate with respect to y and taking x as a constant. So these are the procedure to evaluate the double integral. Now let us understand the concept by taking a numerical example. So here the first example is evaluate the integral from 0 to 2 and then 4 to 6 xy plus p to the power x with respect to y and x. Here one thing is to be noted here, that all the limits are constant. So here a very important question comes in our mind, that which limits represents the values of which variable. Okay, so here we apply a very simple convention. Okay, what we do here? Suppose it is divided here. So here the innermost integral sign for the is for the internal variable, like this. So it means it represents the limits of y, and simply this outermost integral sign is for x. Okay, suppose if it is written like this one, x y, suppose this is dx dy. So here what will happen? This internal integral sign is for x and then it is for y. This is a common rule we apply when the variable, when all the limits are constant and it is not mentioned that which limits are for which variable. In this situation we apply this common rule. It means that this 4 and 6 is for y and 0 2 for the variable x. So here we have to make this one, see. So here all the limits are constant. So what we can do here, we can choose any order. Okay. So let us use the same order. Like since here this integral sign is in the internal mode, so what we will do here, we will firstly integrate the function with respect to y and then with respect to x. Okay. So I will show you how it is done. So the first integral sign is evaluated with respect to y. Remember, as I have just explained you that while evaluating the function, integrating the function with respect to y, we will have to take x as the constant. So here x is a constant term. Okay. So in this situation, x comes outside and y is integrated like this. So what is the rule here? So the rule is very simple. The rule is as you know, y to the power n dy. What the rule is? Y to the power n plus 1 upon n plus 1. This common formula, this standard formula is used to integrate y. So for using this formula, the integral of y becomes y square upon 2, and another result e to the power x exponential, and we know that the integral of e to the power x is same, that is e to the power x, same. Okay. Now after and you can see while integrating y with respect the function with respect to y, we have retained x as the constant term. Now let us apply the limits. So firstly we will evaluate the integral for outermost upper limit and then minus lower limit. So just put here the value of y equal to 6. So 1 by 2 into x into 6 square plus 6 into e to the power x minus and then the lower limit, this one. Now after simplification it comes like this one. So this is the simplified state. Now you can see that the double integral has been converted into a single integral, and now from here it is just a matter of 12th standard. Okay. So what we are doing? We are going to integrate the integrand with respect to x, like 10 into x. So it becomes 10 into x square by 2 by using the same formula. Same formula we can apply here. Same, and then again evaluating the limits for x equal to upper limit minus x equal to lower limit. So this is the result. This is the result. It means 18 plus 2 into e square, and this is the result of the first double integral, like this. So I hope you are enjoying this lecture. So let us have one more example. See, in this example you can easily see that here all the limits are not constant. One limit is in the constant form and another is in the variable form. So how we will know that which variable? Here the common rule does not apply here. So what we do here? Since it is clear from here, it is very clear, just observe all the integral signs, okay, to identify that which limit is for the which variable. To identify it, just concentrate on that integral sign in which variables are involved, like this. See, in the first integral sign there is only 0 and 1, so just ignore it for a moment. Now concentrate on this integral sign where the variable x comes. So what we will do here? Which variable is missing? Here y is missing. So it means it represents the limits of y. So if this is the limit of y, then the remaining limits will be for the variable x. So here we can write it as like, see, you can clearly see that this is the limits of y equal to 0, and this is the x equal to 0 to x equal to 1. Now again the same rule that we have to integrate the integrand with respect to what? With respect to y, because the limits of y is now in the variable form. So while evaluating the integrand with respect to y, we will note down that here x is a constant. So not only 1 is constant, but also the x is constant. So as a whole, to simplify the steps, to make the integration simple, what we will do here, we will assume 1 plus x square as a single constant. Just substitute this value by a, so that this 1 plus x square will become a square. It becomes very simple. Now here we can integrate this function 1 upon a square plus y square. And how we are going to do it? By using a very standard result. And what is the standard result is? The result is, see, the standard result says that the integration of a square plus y square dy equal to equal to 1 upon a into tan inverse y upon a. This is a standard result. So here we have applied this result here. So 1 upon a into tan inverse of y upon a. Now after integrating this internal integral, we are going to evaluate the limits. So the first limit is, we have to first evaluate it for the upper limit y equal to a, because if this value under 1 plus x square will become a. So here this is the upper limit. Now put the value of upper limit y equal to upper limit like this, and then minus into y equal to lower limit. So this way it becomes 1 by a into tan inverse 1. And tan inverse, what is tan inverse 1? Tan inverse 1 is nothing but the pi by 4, that is 45 degree. So in the radian it is written as pi by 4 minus 1 by a into tan inverse 0. And what is the tan inverse 0? Tan inverse 0 is 0. Like tan 0 is 0, so tan inverse 0 is also 0. So in this way, this whole result becomes only 1 by a into pi by 4. Pi by 4. Okay. So pi by 4 is a constant term. Just put it outside, and now this is the 1 upon a. So we have to remember one thing, that a is not the constant in the initial stage. This is the constant which we had assumed. So now again we have to replace this a by how? We have to replace this a by under root 1 plus x square. So now we have applied 1 upon under root 1 plus x square. Okay. So we have to again integrate it by using the standard result, and the standard result is here written. You can read here. This is the standard result of 1 upon integration of 1 upon under root a square plus x square equal to log of x plus under root a square plus x square. So this is the standard result which we have just applied here. Now we have to evaluate the limits. The limits are very simple. So just put x equal to upper limit minus x equal to lower limit. See. and this result becomes like this. So after simplification, it comes out to be equal to pi by 4 into log 1 plus under root 2. So this is the final result of our integration. So I hope you have understood, and if you have any doubt, you can contact me. So I hope you might have enjoyed the lecture, and let us meet again in the coming lecture. Thank you.